Uniqueness of prices. This section has so far focused on characterizing the implementable social choice functions. What about the payment functions? It turns out that the payment function is essentially uniquely determined by the social choice function. Essentially means that if we take an incentive-compatible mechanisms with payments pi and modify the payments to pi prime of v1, v2, v3 until vn equals to pi of v1, v2, v3 until vn plus hi of v minus I for an arbitrary function hi that does not depend on vi, their incentive compatibility remains. It turns out that this is the only leeway in the payment. Theorem 9.37 assume that the domains of preferences vi are connected sets in the usual metric in the Euclidean space. Let f P1, P2, P3 until Pn be an incentive-compatible mechanism. The mechanism with modified payments f P1, P1 prime, P2 prime until Pn prime is incentive-compatible if and only if for some function hi which maps from vi, the domain of preference, to R, we have that pi prime of v1, v2, v3, and so on until vn equals to pi of v1, v2, and so on until vn plus hi of v minus I for all v1, v2, v3 until vn. Proof. The if part is clear since hi has no strategic implications for player I, so we need only prove the only if part. Assume that f p1 prime, p2 prime, and so on until pn prime is incentive compatible, and for the rest of the proof fix some I and some v minus I. For every little a in capital A denote v to the a equals to the set little vi in capital Vi such that f of little vi little v minus I equals to a. Using proposition 9.27, the payment p of vi v minus I is identical for all vi in v to the a and will be denoted by pa. Similarly, we denote pa prime equals to p prime of vi v minus I for some vi in v to the a. It now suffices to show that for every a b in a little b in capital A, pa minus pb equals to pa prime minus pb prime. For little b in capital A, we will say that little a and little b are close. If for every epsilon greater than 0, then there exists vi to the a, vi to the b in capital Vi, such that the norm of vi to the a minus vi to the b equals to the maxima of the absolute value of vi to the a of c minus vi to the b of c, where the maxima is taken among all c in a, and the result of the maxima is less than or equals to epsilon. And the f of vi to the a v minus I equals to a, and the f of vi to the b v minus I equals to b. We will first prove the required pa minus pb equals to pa prime minus pb prime. For closed AB, fix vi to the a, vi to the b in vi as in the definition of closeness. Since a bidder with type vi to the a does not gain by declaring vi to the b with payment p, we have that vi to the a of a minus pa is greater than or equals to vi to the a of b minus pb, and since the bidder with vi to the b does not gain by declaring vi to the a, we have that vi to the b of a minus pa is less than or equals to vi to the b of b minus pb. Putting together and rearranging, we have that vi to the a of b minus vi to the a of a less than or equals to pb minus pa, which is less than or equals to vi to the b of b minus vi to the b of a. Similarly, by considering the mechanism with the payments p prime, we have that vi to the a of b minus vi to the a of a less than or equals to pb prime minus pa prime less than equals to vi to the b of b minus vi to the b of a. But now recall that the absolute value, the norm of a vi to the a minus vi to the b, is less than equals to epsilon. And thus, the upper bound and the lower bound for pb minus pa and for pb prime minus pa prime are at most 2 epsilon apart, and thus the absolute value of pb minus pa minus the term pb prime minus pa prime, the absolute value is less than equals to 2 epsilon. Since epsilon was arbitrary, pb minus pa equals to pb prime minus pa prime. To show pb minus pa equals to pb prime minus pa prime for general, not necessary clause a and b, consider b is equal to the set little b in capital A such that pb minus pa equals to pb prime minus pa prime. Since pb minus pa equals to pb prime minus pa prime, and pc minus pb equals to pc prime minus pb prime, implies pc minus pa equals to pc prime minus pa prime. We have that no alternative in capital A minus capital B can be close to any alternative in B. Thus, v to the b equals to the union of v to the little b for all union for all index little b in capital B has positive distance from its complement, v to the capital A minus capital B, which is the union of v to the b for all those little b not in capital B, contradicting the connectedness of v. It is not difficult to see that the assumption that vi is connected is essential, as for example, if the valuations are restricted to be integral, then modifying pi by any small constants epsilon less than 1/2 will not modify incentive compatibility. From this, and using the revelation principle, we can directly get many corollaries. 1. The only incentive-compatible mechanisms that maximize social welfare are those with VCG payments. 2. In the bilateral trade problem, section 9.3.5.3, the only incentive-compatible mechanism that maximizes social welfare and makes no payments in case of no trade is the one shown there, which subsidizes the trade. More generally, if a mechanism for bilateral trade satisfies ex post individual rationality, then it cannot dictate positive payments from the players in case of no trade, and thus it must subsidize trade. 3. In the public project problem, section 9.3.5.5, no ex post individually rational mechanism that maximizes social welfare can recover the cost of the project. Again, the uniqueness of payments implies that if players with value 0 pay 0, which is as much as they can pay maintaining individual rationality, then their payments in case of building the project must be identical to those obtained using the Clark pivot rule. In section 9.6.3, we will see a similar theorem in the Bayesian setting, a theorem that will strengthen all of these corollaries as well to that setting.